shortest path algorithms. So, generally given a graph, when you are given a graph something like this which represent different cities, okay, you are having different paths, you are having a very big graph with you where each vertex represents a different city, okay, like this you are having a big graph. So, you want to reach this city C, okay, from city A or from city some j, from here you want to reach this city C, you have to find out the shortest path. So, we know that we are using graph theory for solving our general real life problems. We use graph concept or graph data structure. Yesterday we have seen the example of placing the fire stations. So, those kind of problems, real life problems or real time problems, we try to convert that problem into a computer science problem and represent it as a graph. So, I have a map of a state or maybe some region. I want to find out the shortest path from this node to this node. How do I go? Right. So, this is for weighted edges, where weight here there is some value weight. Okay. This can represent either time or money. Okay. This can or distance. It can even represent time or money or distance depending on the situation. So, given a graph, how do you find out the shortest path? Okay. So, there are multiple types of problem here. I will talk about this Warshall's algorithm. Let us see about this Dijkstra algorithm first. What is the use of Dijkstra algorithm? It will tell you, you choose any one vertex in this graph. Suppose I choose F, okay, from F, okay, from F, what is the shortest path? What is the shortest path from F to J to A to B to C, D, G, E, from this single node F to all other vertices. So, maybe if I take a simple graph like this, okay, D I have some other node, I have E also I have here like this. Okay. Now, if I choose a vertex A from here, from this source A, I want to find out the shortest path to reach from A to B, from A to C, from A to D, from A to E, that is it. This is what I have to find out. I want to find out the shortest path from a single source, from a single source A. This we can give as the input, it is our choice. You can either select E or C or D, anything. From a node A, right, you want to visit, you want to find out the shortest path to all the other vertices. For that we use Dijkstra. Now, let me come up, that is Floyd-Warshall's algorithm. What is this significance or importance of this Floyd-Warshall algorithm? This Floyd-Warshall algorithm will help us in finding out the shortest path. See, Dijkstra is helping us, it is taking input only one vertex. It is taking only one vertex as input. If I give A, from A to B, C, D, E, it is telling the shortest path. But Floyd-Warshall algorithm, it will tell you the shortest path from all the vertices to all other vertices, meaning from A to all other, from B to all other vertices, from C to all other vertices. What is the shortest path? Okay. In a single go, Dijkstra is giving only for one vertex. What is the shortest path from A to all other? Floyd-Warshall will give you shortest path from A to all other, B to remaining all four. It means from A to B, C, D, E, it is telling what is the shortest path. From B, it is telling to A, C, D, E. Okay. From C, it will tell you for A, B, D, E. From D, A, B, C, E. Like this, it will tell you shortest path for all other nodes, right. From for every node, it will give the shortest path in a single go. That is our Floyd-Warshall algorithm. So, before this solution was proposed, Floyd-Warshall, first Warshall solution was proposed, then a updated version or a modified version of Warshall's algorithm gives us the shortest path. In fact, Warshall's algorithm is it is just to give us the reachability matrix. Okay. It will generate a matrix which is similar to our adjacency matrix. It will take the adjacency matrix as the input and give us the reachability matrix. This reachability matrix will help us in finding out the all pair shortest path, all pair shortest path, meaning from A to all other vertices, from B to all other vertices, from C to D like this from everywhere, right? So Warshall algorithm helps us in finding out the reachability matrix, or the approach in Warshall algorithm slightly if we modify that becomes fluid Warshall. Okay, so this is for all vertices the shortest path. This is for single vertex only. Okay, so let's try to explore these three things. Let's study the Warshall's algorithm first. Okay, what is this Warshall's algorithm? Right, Warshall's algorithm is specifically designed to find the transitive closure of a directed graph. Okay, this is used to find out the transitive closure of a directed graph. What is this transitive closure? Transitive relation, if you know transitive relation in set theory of discrete mathematics, you might have studied, right? If I have a set A, B, there is a path, and then B, C also there is a path, then I can say A, C there is a path. Transitive relation. Okay, A to B, B to C, therefore A to C, right? So in a graph, if I have a graph like this to C and to D, okay, A to B there is a direct path, but A to C, is there a direct path from A to C? No, there is no direct path from A to C, but can I reach C in some other way? Yes, you can reach from A you go to B, from B you can come to C, there is a path, right? So this Warshall algorithm helps us in finding out the path, okay, from A how to reach to C, from B how to reach to C and D. See, I am able to reach A to B directly, A to D directly, but not to C, So is there any path possible to reach from A to C? That will be given to us by Warshall's algorithm. Okay, next, from B can I reach A? From B can I reach A? No, from B I cannot reach A because there is no direct path. But can I go to C and D and come A? No, that is not reachable from B. So that kind of conclusions we will be getting using this Warshall's algorithm. Okay, from C I can reach B? No. I can reach D? Yes. I can reach A? No. Okay, it depends on the problem. But if I have something like this, a arrow and again a double arrow here, now you can see that we can reach every vertex, right? How? From A to B there is a direct path, from A to C there is a direct path, from A to D there is a direct path, A to C there is no path. I can still travel either from A to B and to C, or A to D and to, no, that's it, only one way I can come, this. A to D is direct. From B, how to reach D? C it is direct path, D there is a path. A, if you want to go from B, if you want to go to C, it is easy, direct path. To D, yes, you can come in this way. To A, yes, you can come in this way, right? So Warshall algorithm helps us in finding out whether there is a path, can we reach that vertex or not, directly or indirectly, maybe direct way, or by combining 2-3 edges, can we reach there or not, that will be given to us by Warshall's algorithm, right? So transitive closure of it means it gives us the path, actually it will give the path matrix, path matrix, meaning directly or indirectly can I reach to that vertex or not, that will be given to us. What is the input for this Warshall's algorithm? A directed graph represented by adjacency matrix is the entry. In this adjacency matrix, if there is 1, there is a path, if there is 0, there is no path between those vertices. What is the output? A transitive closure matrix. Okay, a transitive closure matrix, right? If there exists a path from node I to J, it will put 1, either directly or through other nodes. Can I reach from A to C? There is no direct path. Can I reach C using help of other nodes? That also will be given to us in the transitive closure matrix. Okay, so the idea is very simple. Iteratively check if each pair of vertices can be connected through an intermediate vertex, right? To connect to A to C, if I had one more vertex here like this, okay, A to B is direct, A to D is direct, but A to E is it direct? No, I can go from A to B, B to C and E, or I can go from A to B, A to D and E, but somehow there is a path, not directly but indirectly. Okay, so this will tell us, it will give us a matrix where it will tell yes there is a path, you can reach E, either directly or indirectly you can reach E, that will be known to us, right. So, for each node k it updates the path between pair of nodes. Okay. So, let us see an example and try to understand how this Warshall's algorithm work. Let us take a small example and see the working of this Warshall's algorithm. Input is adjacency matrix, output will be a transitive closure matrix which gives us the information that we can reach every vertex or not. Okay. Let us see this example. Let me take a small example. A to B there is a path, and from B there is a path to D, and here I am having C. Okay. And from A to D there is a path. I am taking a small graph, A to B, B to D, and yes. Now, let us write the adjacency matrix for this. Okay. So, we are trying to find out the reachability matrix. This matrix which we are using is called reachability matrix. The transitive closure is given to us in reachability matrix. So, I will take R, initially the original one. Okay. How do you fill this, right? So, I will write R0 equal to A, B, C, D, A, B, C, D. Okay. From A to B there is a path, yes, no. From A to A there is no path, that is 0. A to B there is a path, A to C, no. A to D also no. No direct path. R0 is your direct path matrix. Then B to A, no path, B to B also no, B to C, no path, B to D, yes, there is a path. Next, C to A, no, C to B also no, C to D, this is all zeros. Then D to A, yes, there is a path, D to B, no, D to C, yes, D to D, 0. So, this is the original matrix. I am trying to find out the reachability matrix or the transitive closure of this matrix. Okay. So, what we are trying to do here, right. So, now the next step is to, right, you have to choose A. Okay. First we have to choose A. Just a second. Choose A. Now, what is this point? Using A, can we find out paths for other vertices? Can we find out paths for other vertices? Assuming A as the intermediate node, taking A as the intermediate node, can we find, see, is there just an example you see here. In this example, is there any path from D to B? Is there any path from this node D to B? Do we have a path? No. But using A, can I get a path? Yes. From D you can go to A, and then from A you can come to B. There is a path, right. That is what choosing A means. With the help of A, can we create path for other vertices which do not have a vertex, which do not have a edge. Okay. Using the vertex A as the intermediate vertex, can we create path or can we show a path to other vertices when you choose A, for example. So, when you choose A, right, I will write RA. Let me write that matrix here. When you are choosing A, you should not touch the first column and the first row. You have to write it as it is here. So, this is 0 1 0 0 and this is 0 0 1. Okay. So, I will just write it here, RA equal to A, B, C, D, A, B, C, D. Because using A, you cannot show path to A. That is not possible. Only to B, C, D you can show. That is why I fixed it like this. Okay. So, and wherever there is 1, that will be also same, because already there is a path. We need not show any path to them. Only wherever there is 0, we have to show the path. Now, let us take. So, what is this box? What is this box? Where is 0? Here we have a 0. So, B to B. Now, can we create a path for B to B using A? How to show that? B to A and A to B. Can we show a path like this? Okay. Now, come to R0 matrix. Come to R0, the original matrix. B to A. What is the value? B to A? See, it is 0. And what is A to B value? 1. 0 and 1. If both are 1s, then there is a path. If anyone is 0, there is no path. So, we cannot change this. This is only 0. Okay. B to A, there exists no path. So, you cannot use A as an intermediate node to create a path from B to B. Okay, so this is 0 and 1. Even you can assume this as bitwise AND. No, this value is 0, this is 1. Bitwise AND means if anyone is 0, it is 0. Okay, the rule here is if both the values are 1, then only you can create an edge. So B to A not possible. Next 0 is this part is empty, that is 0. I have to fill it. B to C. So B to C. I want to show a path to from B to C using A, meaning from B to A first and from A to C. So refer R0 matrix. What is B to A value? 0 and A to C value 0. 0 means there is no path. So this cannot change. This will be 0 only. Then from next empty bracket is here, C to B. Okay. Next is from C to B. So C to B. Can we create a path? Can we show a path? Or is there any path from C to B with the help of A? Meaning from C to A and from A to B. See the matrix. C to A, is there anything? 0. And A to B 1. 0 and 1 means it is 0 only. This also I cannot create. Next. The next one will be from C to C. Okay. Is there any path from C to C? So C to A and A to C. So C to A value is 0 and A to C value is also 0. Therefore, I cannot have using A, there is no see this meaning of this RA matrix is using A as an intermediate node, okay, as a mediator between two different nodes. Can we have a path? That we are trying to see. Then C to D. C to D. Here if you see, it is C to A and A to D. Okay, C to A it is 0 and A to D it is 0. So no, not possible to have a path 0. Next go to this box, D to B. D to B. I want to show a path from D. See, this will work here. This is very important. So D to B, I want to show a path using help of A. Can we do that or not? So check D to A and A to B. What is D to A value? 1 and A to B value? A to B value here it is 1. 1 and 1 means yes. This 1 indicates that there is a possibility of having a path from D to B. Next D to D. D to D. Is it possible using A? Let's see that. Okay. So that is from D to A and A to D. D to A, yes, it is 1 and A to D, but it is 0. Therefore, I cannot have a path. Like this, we have found out the RA. What does this RA reachability matrix A indicates? It indicates that no, from using A as the intermediate node, we are trying to find out whether I can reach all the other vertices or not. Okay, I am trying to show a path using A. Via A, do we have a path from some nodes which originally does not have a path, but we are trying to show. Next, choose B. Next, choose B. Okay. So when you choose B, you have to always refer this RA matrix, not this R0. Okay. So I have to fill this matrix RB. A, B, C, D. Okay. So since we are choosing B, you have to freeze these two columns, this row and this column and this row, we have to freeze it. We cannot change that. So this is 1, 0, 0, 1 and this is 0, 0, 1. And wherever there is 1 also, we need not do anything. This is all ones. Remaining places we have to fill. Okay. Using B, we have to try to fill that. Let's do it. So first one is A to A. Using B, can we show a path from A to A? Okay, right? Let's see the next step. So I have to fill these remaining which are having zeros. Okay, so I want to create a path between A to A using B. So A to B as the intermediate and B to A. So see now this matrix is not required now. You need not refer to this. You have to refer only to RA, the latest matrix. Okay, that is RA. So A to B there is 1 yes and B to A it is 0. So no, I cannot have a path. Next I have to show between A to C using B. So it is A to B and B to C. Is there any path from A to B? From A to B, yes, there is one, and B to C, no. So this is also 0. Next I have to show for A to D, that is A to B and B to D. Okay, so A to B there is 1 and B to D there is 1. So it means I can reach from A to D, I can reach from A to D using B. This is clearly visible, no? I can reach to D via B. That's why it became 1 now. Okay. Next, we have to fill C to A, C to A. So here C to, I am using B as my intermediate, C to B and B to A. What is C to B value? Here C to B is 0 and B to A is 0. Anyhow, this is 0, we cannot fill this. Okay. Next, from C to C, C to C, that is C to B and B to C. Okay, C to B is 0, B to C is also 0. So this is 0. Next, C to D via B. So C to B and B to D. What is C to B value in this matrix? It is 0 and B to D. B to D is 1. Since 1 is 0, this will be 0. So no change in that. Okay. Next you have left over the D to D. Now from D to D, can we show it a path using B? So it is D to B and B to D. So refer this RA matrix. What is D to B value? 1 and B to D value 1. Yes, I can reach, right? So we can reach from this D to D using the B matrix. Okay, so this is what we got, right? This is using B as the intermediate. Now let's take C as the intermediate. Okay, let's find out whether there is a path from every vertex to every other vertex by choosing C as the intermediate node. Now this is not required. We have to refer RB now. Okay, so when you are referring, when you are choosing C, that C column and C row will be fixed. We cannot change this. And this one, that is 0, 0, 1. And wherever there is 1 also, we need not worry, because there is already a proof that there exists a path. So 1, 2, 3, 4, 5. Oh no, only 1, 2, 3 I have to fill. These 3, this one, these 3 I have to find out using C. So it is between A to A. Okay, A to A using C, that is A to C and C to A. A to C, what is the value? A to C, it is 0. Any other one will be definitely 0. So this is 0 only, no change. Next you have to fill B to A. Can we use C as an intermediate node and show a path from B to A? So that will become B to C and C to A. What is B to C value? B to C value in this matrix, B to C is 0. So obviously the other one also becomes 0. I cannot show anything. Next one is B to B. Using C as an intermediate node, can we create a path from B to B? So it is B to C and C to B. So in this matrix, B to C is 0. Obviously other one also becomes 0. This is the final one. Okay. Now let's take D as a intermediate. Choose D now, that is RD. RD will become A, B, C, D. Here also A, B, C, D. So you have to refer the RC matrix now. You need not refer this RB, you have to refer the RC matrix. So what is then RC? Since I am choosing D, that D row and D column will be fixed. We cannot change that. So 1, 1, 0, 1. Here it is 1, 1, 1. And where is 1? Only 1 is here. Remaining all are zeros. Okay, remaining all are zeros. Now try to fill this matrix using D as an intermediate node. First one, this one, that is A comma A. So it means A to D and D to A. Okay. So A to D, there is a edge, there is a 1, right? 1. And what is D to A value? It's also 1. Therefore this will become 1. It means I can reach A starting from A, I can come back there. There is a path to reach from A to A. Yes, no? From A to B, B to D, D to A, I can reach from A to A back. So that is the proof we are getting here. Next is A to C. A to C means I have to use D as my intermediate node, that is A to D and D to C, D to C. See here, A to D is 1 in the RC matrix, and D to C is also 1, there is a path, therefore I can reach from A to C also. Okay, right. How you can reach A to C? From A go to B, go to D and go to C. This path, this from A to B, B to D and D to C, I can reach it. That's why it became 1. Okay, this Warshall algorithm helps us in finding out whether can we reach to that vertex or not, directly or indirectly. Next is B to A. B to A can we reach or not using D, that is from B to D and D to A. What is B to D value? B to D value is 1 and D to A value is also 1. Therefore, I can reach from B to A. How? B to D to A. From B you go to D, then come to A. Okay. Same way. Next it is from B to B. B to B. That is for B to D and D to B. Okay. So, what is B to D value? B to D value is 1 in RC matrix and D to B is also 1. Therefore, I can reach from B to B also. Next one empty here is B to C. B to C. So, using D as temporary, that is B to D and D to C. Check this RC matrix, what is B to D value? It is 1. See, B to D value is 1 and D to C. What is D to C value? It is also 1. Therefore, I can reach from B to C also. How? B to D you go, D to C you can come. That is it. Next, C to A. Next is C to A using D. Okay. So, that is C to D and D to A. C to D in this RC matrix, C to D is 0. Therefore, this will be 0. We need not verify that remaining part also. Next, C to B. C to B means C to D and D to B. What is C to D in this matrix? It is 0. Then definitely this also will be 0. Again C to D, this also will be 0. Right. So, this is your final matrix. So, this final RD matrix, okay, this is your reachability matrix. If you see this 1 1 1 1 1 1 1 1 0 0 0 0 and 1 1 1 1, meaning from A to A you can reach, from A to B you can reach, A to C you can use. Using some nodes, using some intermediate nodes, we can reach from A to all 4, from B to all 4, from C we cannot reach anywhere, because you see C is here. Is there any outgoing out path from edge from C? No, everything is inwards only, there is no outwards. So, I cannot reach ABC or sorry ABD from C. Then fourth one, from D I can reach everywhere, I can go to A, I can go to B, I can go to C. So, this Warshall algorithm helps us in finding out a path matrix or a reachability matrix. Okay. This is also called as transitive closure. This is also called as transitive closure. Right. This is helping us in finding out whether there exists a path directly or indirectly from one vertex to all the other vertices. You can take any vertex here, from A to B, from B to C, B to D, anywhere, any vertex to any vertex. Can we reach or not? Is there any path or not? Path matrix, right? So, this is about Warshall's algorithm.